Am I audible? Fine. To introduce myself, I'm Dr. Victor from associated with since 2018 onwards. Okay, so I welcome you all. And before I start the topic, I just want to know, the faculty who handled the last session, Dr. Jayesh, is also my colleague. And but I want to know, from him I just learned that people are from different domains and different streams. So can I have some idea, how many are from computer science and data science based, or something like AI or data science and cyber security? So can I have some idea, maybe raising hand or anything like a cyber based? How many of you cyber based? Data science, AI based? So other side just make a combination of both. Okay, so once I received the topic, this is going to be the topic, I was little confused. Okay, so what I actually expected, because the topic is going to be something like AI based implementation. So I was little confused what actually expected, whether they want to implement the algorithm using AI or they want to learn about AI and then about supervised learning. There is a confusion. Anyway, I just gone through all other topics, what is going to be part of this FDP, then I got some idea. Okay, one thing I want to make sure, I will have some idea, question, to understand how much, as though this topic is completely related to cyber. Okay, cyber security, offensive, all those things. Since every topic is associated with or attached to the term AI, let me have some thing with idea what is AI. See, I am not going to talk completely. We have a maximum of 1 hour of hour. I guess you could almost all our faculties, right? So maximum of 1 hour we can have continuously. After that, it may not be possible to continue for 2.5 hours anyway. So I will try to make it interactive, as just how a session happens. Just try to interact. Whatever it goes, let's see. Okay, so let's see, I want to make sure what you people expect an AI, what you people think an AI, not respect to cyber, just let me know what you think of what is an AI. AI is a, of course, it's a typical student answer anyway, but what it is means as a faculty we know this is not the answer what we want, right? What is an AI? Yes? Mission act like a human. Okay. Anything else?
Intelligent machine with multiple agents.
Intelligent machine with
multiple agents.
Multiple agents. It is not necessarily multiple agents. Intelligent system is something that it should have AI, right? Yeah. Anything else? So you are what actually one of the participants, faculty, or they said we are going to imitate the behavior of human intelligence, or we are going to imitate human intelligence onto a machine, right? That is what actually AI. Now, if I ask what your perspective, what are the AI systems you have seen? What are the AI systems you have seen visually or maybe somehow? What AI system you have seen? We are talking all about AI. If I ask you what the AI system you have seen, what do you say? Yes? Chatbot. Good. Anything? Spy? Spy or cyber security? Okay, fine. Hey, I want to be open I'm not a cyber guy, I'm a DSAI guy from CSE, and I have specially worked for this, this maybe the session, by taking some related to their cyber related thing. Anyway, I will show what are the outcome is going to be cyber related only, not with AI. But before that, I want to make sure of AI basics and what is machine learning, all those related thing I want to touch up. Because I feel the FDP in such a way straight away jumping into AI based all cyber thing. I want to touch up basic things, okay? And even as said, AI based implementation of the model, then you will not have neither of understanding what is AI or the model. Okay, so if you straight away say I can tell just open by GPT, tell them to implement this particular supervised model for this particular data set of cybersecurity related data set, then it does everything. Are you getting? So once we know like what actually we are expecting from that, maybe the prompt engineering, or I guess like you people might have come across something like vibe coding, like vibe coding. Even if you want to look up into the vibe coding based implementation of this, then you should know like what actually you are expecting from the GPT. Then only you can. Even the GPT chief itself says like, if you know what is the outcome you are going to get from the GPT, then use it. Otherwise, don't use it. I hope you understand what I am trying to say. Okay, so example I can say like, if you ask GPT about normalization, you may get output related to normalization associated with DBMS, normalization associated with the data science. Only if you know what you want or what you are expecting from it, then only you can interpret it as like you want. Are you getting? That is what actually I am trying to say. Even rather than directly going into implementing using AI, I want to make up like what is it, what the outcome you are going to expect from that, so that you can validate. Are you getting this? So that is the plan. So as like what I expected, like what is AI, maybe I will go with the presentation, the topics, these are the topics, the plan. So I will be touching up what is AI, background, and I will be talking about AI system, and then I will talk about data science. Actually data science is not completely away from what is AI. So if you want to make an AI system, apart from maybe I will talk about robots, okay? Apart from your hands, otherwise you will call it as actuators. Maybe if you have handled the AI course or any time associated with AI, you might be talking about something like a peace. Have you ever heard of peace? Because these are the terms that are associated with AI. Peace, performance, anything environment, actuator, sensor, anything like that. So those are all you need to know like before you are making a AI system, not necessarily your cyber, any kind of AI models. Okay, let me tell you, whenever I talk about like robots, okay, robot you will say like even the very first slide I will be talking about like this, what comes to your mind, primarily these are the things what we were thinking about what is AI, maybe I can say before data science come into picture in the curriculum. Yes or no? So this is So this is what we thought of like what is AI when we were before data science AI is coming to picture. Okay. Now and then afterwards we are going to get into details. If I go for this, see even if you take any machine, any robots, okay, AI is not about your hand, AI is not about its legs, AI is not about eyes. If I say AI, where actually AI lies? Yes? Where AI lies. If I say a robot, a humanoid robot is standing here, if I say this robot is having AI, what it means actually, where the AI component is? Yes? Brain. Because humanoid robot doesn't have a brain. Where the AI lies. If I'm saying like, see, you take Romba, you know Romba, right? So that's clean the room. Any machine, you take your Tesla car, it's AI, right? Yes, Tesla is AI car, but apart from it is a car, where the AI is there into the car. Any idea? What actually means AI there? Chip? Processor? No. Then that means even our CPU is AI, right? It's not. Then where actually AI lies? If I say like any robot, any machine, any system, where AI lies there? It is nothing but a algorithm. Algorithm is a very old term. Now it is not algorithm. There is another new term is there. What do you will call it? Is a yes. That term you have to use is model. The model is nothing but the AI component actually. So if I say even you take this robot, so as I said like a piece, something that will be coming across piece. This is nothing but performance and environment, actuator, and then sensor and actuator piece. Okay. So now if you take, see the eyes senses what is in front of it. So it will just like us, it send the data to the backend. So there will be some component that is receiving the data just like our brain, receiving the data and going through some kind of execution and coming up with a decision, whatever in front of me is either a car or a person or a backend space so that I can move. Are you getting? So there is something inside that takes the input, process, and it gives the decision how to proceed. Based on that outcome, the actuator does, whether moving the leg or moving the car forward, anything. Are you getting? So whatever we are telling that A, that is nothing but the A model, what is there inside the thing. That takes the input and it gives you the decision whether it is this or that or anything else. Based on that response or maybe the outcome of that model, the particular humanoid robot or anything takes the next step. Whether if it is a vehicle, okay, whatever in front, it is the vacant space, okay, move forward. Whatever is in front of me, segregated, yeah, it is a human, so you have to brake. Are you getting? So the part, what I am saying A, it is nothing but the module that is inside takes input, produces the decision. Are you getting? So that is the A. Are you getting this? So that is nothing but you will call it technical as a agent. That is what there are different terms are there. So whole thing will be a intelligent system and the small part that is going to be called as an intelligent agent. So whoever associated with agent technology, you might have come across. Agent is nothing but that senses, perform some calculation and do some task on the environment. Okay, so that is what typically an agent. So intelligent agent senses, gives the input to the model and model will give you the result or maybe the decision to proceed further. Now, whatever we are going to talk about, whenever we talk about AI, that's nothing but the model. To build that model, you need data science. Are you getting? So data science, AI, intelligent system are all not different. Okay, if I'm saying I'm going to build an AI system, then I need to have a model. That is where your data science lies. Are you getting? So the whole thing going to be revolving around data science, artificial intelligence, machine learning, deep learning, everything is going to put together. The model, as he said, we are going to make a brain. The brain is nothing but the model. Are you getting? So that is what the detail is going to. That is why I want to relate AI, data science together, because I will be concentrating more on data science, which is nothing but the model, preparing or making the model using different algorithms. Okay. So getting into the next, so I want to give some basic idea. Maybe before getting into what is AI, all those things, I want to talk about one guy like who is McCarthy. Any idea? The guy who is on this slide? Yeah, Paul. Is it there? No. Yeah, actually he is the one who actually coined the term artificial intelligence. Any idea which year? Okay, it was way back 1956. I will tell you something like there was, maybe you might have known some person called Turing, the guy Alan Turing, who is the guy who prepared the test to check whether there is human or a system. Okay, response based. Then there is a person called McCarthy who actually gathered a set of people. Okay, even there is a primary people like McKenzie, and he is from a professor associated with Dartmouth University by that time. Okay, so they gathered some people like I think around 20 people who are experts in different domains, mathematics, statistics, physics together, and they worked for some whole summer. Okay, and they derived the term artificial intelligence. From there the work happens, and then they derive very different things which are related to AI. We will go by one. Okay. So actually there is a term I just put up like this is a universal field. Any idea like why this universal field? Why it is called as a universal field? Universal field. AI is a universal field, of course, right? Why? Because it can be applied in any field, regardless of that, finance, regardless of crime, all the domains. So the term it's associated with this universal field is because it is applicable in all the areas of the domains, different fields. Okay, that's fine. Let me go. I don't want to talk about other fields like what is AI, Victor and all to get more deeper. I will ask about few things only. So if you think about AI refers to the simulation of human intelligence in machines designed to think, learn and solve problems like human. Okay, there is a term associated. Okay, think, learn and act like a human. If you look at the human, in this case the human, what it means, I can say like it is a benchmark. Are you getting? Intelligence is associated with humans. But here we will be talking about like whether humans are the most intelligent living things. If I ask, what will be the answer? Well, it will be yes or no. It is not about like only human. If you see like, see, I can tell you, maybe I don't know like how many of you are aware of this. Like does maybe sense the earthquakes even before a week time. Have you ever heard of this? And even the birds even understand tsunami, everything, even many days before it's going to happen, anything. See, even I can tell you, like the elephants remembers the path they used to walk or maybe hundreds and hundreds of years before onwards. And maybe I can tell you, like the bird that goes for what do you call migration from west to east, and they dies there. Even the smaller kids come back to the original place. Are you getting? These are all nothing but intelligence, which we don't possess. So intelligence is not about human, it is about doing the thing perfectly or correctly. Are you getting? So no matter, even if you take like a dog, which have better intelligence with respect to sensing than human. Are you getting? So intelligence, as per this, yes, it is human, but humans is not going to be benchmarked with respect to considering a general intelligence, which we are going to talk about. Narrow AI and general AI. I guess you know what is that. Narrow AI and any idea what is those two? General AI. What is narrow AI means? Any AI agent or intelligent machine that does only specific task. If you take your Gemini, you just ask it to draw a diagram, it won't. It will say like I am not trying for that. Okay, you any idea like what is the Deep Blue? Any idea like what is the Deep Blue AI system? What is Deep Blue? It's a supercomputer. Deep Blue. No, I am asking for AI system. Deep Blue.
It's a supercomputer defeated human chess.
Yeah, there is a one AI system that defeated who? Human means who is there? Yeah, it's a Castro. Okay, Gary Castro. So what I say, like if that machine, you take that machine, if it asks you to play cricket, it won't. Are you getting? Such an intelligence we will be calling it as a narrow intelligence. And general intelligence is nothing but just like this. If you allow the machine, it can do anything. A same machine, just you take a chicky robot, it can do anything. Say I have example I am saying. It's not like that. Okay, like it can play, it can watch, or it can do any kind of thing, just like a human. Such an intelligence you will be calling it as a general AI. Now maybe I can say like the Google, Meta, all those people are working towards general AI. Actually, it was assumed to be like a not possible at one stage, but now people are expecting it by 2035 or within 40, you will be getting a general AI system. Once maybe I guess like you people should know someone called Jeffrey Hinton. Anybody come across that guy who is Jeffrey Hinton? Recently got Nobel Prize. No. So he is the one who just resigned his Google in 2023, and he primarily talks about like what are the ethical, or maybe I can say like ethical issues you will face once we design the general AI. So there is a lot of things just try to explore. Then we will move fast. I just want to have some introduction to this IQ. So whatever we have made vision so far, AI vision, that are all related to IQ. I guess you know what is IQ. Whatever we have done, it's all about IQ, making problem solving in a better way. That is what. And apart from that, still the researchers are going on to make machines that are specifically good in SQ as well as EQ. I guess you know what is EQ and SQ. So maybe I can tell with respect to the movie. If you take the movie Robot, so they said like that is good in doing something, but not emotionally. Okay, so those are also in progress, under research, making the robot emotional quotient as well. Just like a human, it will have a feel, it will have every kind of thing. And even it's also there's something called SQLs also they are trying to make under the topic called cobots. There is something called cobots where collaborative robots will interactively work just like us, socially understanding everything. Okay, so these are all the researches that are in progress. And just to tell here, if I ask like if I ask you like how long this AI is there, if I ask you people like how long this AI term is there, can you tell me like maybe any idea like how long? I don't know, like anybody have you seen this cartoon show? See, you just try to explore this cartoon show which was maybe telecasted in 1980. Maybe whoever watched cartoon networks that in 1990s, around that period, they might have come across this cartoon show. This cartoon show was telecasted in 1960s, and I can tell you, whatever they have showcased in this particular cartoon show, still we are able to achieve. Okay, even if you want to say like, I want to make one AI model or AI system that doesn't exist, which you want to make the maybe the life of a human better, then you can watch this show. You will have all kind of possible AI missions that a human requires for a day-to-day life, and still more. I can say like most of the maybe I can say like a missions that are showcased in this show are still able to be achieved. And whatever I don't know like whether how many of you know about these things like online classes and online medicine, telemedicine, all these things in before COVID. But this show, it was showed in 1960s itself. People were working about this from long before. Okay, and I can tell you then, there is again one more thing. I'm just making you people from AI into maybe deep learning or whatever. Okay. Yeah, now I told you. So you take the robot. Okay, so what is robot? It's nothing but a cleaning robot. It's an AI system actually. Okay, so it sees whatever the things just beside it and it sucks it. If it is a dust or a dirt, it will suck it and it will ultimately clean the room. Okay, now what I'm saying, so that is going to be something. I understand there is a sensor, maybe infrared sensor or camera will be there. Something is there. So it sensor like just look at what is there. And it takes it and give it to the something I said like something, the model. So it gives to the model. The model decides whether it's a dirt or it's a mat or it will be somebody's leg. Okay. That decision is going to be helpful or back to the system. The system decides whether to serve or to move aside. Are you getting it? So what I am saying, there is going to be something inside that is going to tell the sensor and actuator what to do. So now that one thing, what I am saying, the model, how to build the model, that is what going to be the next step. So this is what actually I am trying to say now. Okay, that is what actually we are going to do now. Okay, now we are going to do something that is going to end up in creating one thing that is called model. So once after you build it, you give anything to test, it will give you the decision. Are you getting it? Could you able to understand what the thing? So the process of making it, you will be calling it as a data science process. Even when you talk about data science, these are the steps you will get when you talk about data science as well. Okay, so initially if I want to tell like this, if I go back to this romba, okay, so what I have to do, I have to collect enough images that are it's going to come across. Maybe image of a floor, image of a human leg, image of different dirts. Different images of mat, all those things I have to create. That is what actually I say like a data collection. Maybe I can tell like this. The data collection, if the problem is specific to Romba, it is clean, assume like that. If it is Tesla, it has to reach from source to destination place without making any accidents. The different problem will be different to different. Okay. So now preparation of data, what I am trying to say, I am going to considering only Romo, the cleaner. Okay, so I have to prepare all the maybe different images and then distance measure everything. Okay, then I have to feed all this data. Okay, before feeding, what I have to do? I have to do some kind of steps that is called explore and analyze the data. So we will do that demonstratively. I don't know like how many of you know statistic based like what is data standardization, what is data normalization, anything like that? Any idea like what is data normalization? Normal, just data and normalized data, what is the difference?
After processing the data, then remove the background noise.
Okay, that is generic term. Of course, background noise refers to many other things, even your outliers, everything comes under noise anyway. But what I'm asking is like, if I say specifically, see, if I'm telling you salary, I should take a salary column, okay, salary of 1,000 people. Maybe somebody will be having salary of 1 lakh, somebody may be having the salary of 1,000. Okay, so now the column is going to have something called a lot of variance will be there. I don't want to talk about formula for variance and statistics variance. So if the variance is too high, the model will not learn better from the data. That is maybe I say like underground philosophy. Okay, so now we have to make the data maybe in a better way. Unless I can tell I need some writer, maybe it would be better for me if I have a writer. Like I can tell you like assume an age of a person, there are two columns. age of a person, okay, and salary of a person corresponding. Okay, if you have the age of the person will be possibly from 20 to 100 maximum, and salary will be from 1000 to lakhs and lakhs. Yes or no? If you use both the columns to train a model, okay, so whatever the field are having very high value will be having more prominence in your model training. Are you getting? When the model learns from the data, the very large value will be having higher impact, which will have an impact on your prediction of your model. Are you getting? So what is mandatory? You have to make all the data within some specific range. Would you able to understand? Now you can make the data to be normalized between one specific range, between 0 to 1 or maybe 1 to 10. All that can be, you can normalize within some range. Are you getting? This is mandatory. Now if you look, if I have the normalized data between 1 to 10, even my age also will be maximum is 10, minimum will be 1. My salary also will be maximum 10, minimum 1. Actually, I'm not going to talk about formula conversion, how you can normalize the data. Okay, so if you normalize it, then both are having equal prominence and model will learn in a better way from the data. So you have to do these kind of pre-processing. Of course, you can relate the term as a noise reduction. That's a generic term. Okay, but there is going to be a lot of steps associated. We will be putting it under pre-processing, data pre-processing, which will make the data ready to support or maybe train a model. You can't just like that you can get the data and you can't use it to train a model. You have to pre-process it so that it will be ready. And even after pre-processing, you have to make something called explore. There is a term called a data explorer. I think you might have come across something called EDA. Exploratory data analysis. Maybe as a faculty, I can tell you one thing, like if I give you 10 students, I am telling you people like these 10 people should get pass. So primarily what you will do? If I say like I am giving you 10 students and you have to make this 10 student pass, primarily as a faculty what you will do? We will try to, yes, you will take class, that's fine. But if specifically 10 students is given to you and to make them pass, as a not as a general faculty, as a good faculty, if I say, what you will do? Yeah, very first thing is you will try to individually understand the student so that how we can individually make them or maybe a group, we can make them in a better way to get pass. Are you getting? So the same is applicable here also. I just pre-process the data is ready. I am going to train it a model. But before training, giving to the algorithm, I need to understand which are all the columns are important to predict what I want. Are you getting? So I can tell you like, assume like I have a data set of a student, okay, or even you can take cyber related also, maybe I will take simple example. Data set of a student, this data set is going to be like a student name, student gender, student age, and the student caste, and the student maybe 10th mark, 12th mark, and CGPA, and I can select a SEM 1, SEM 2, SEM 3 CGPA, and you want to predict SEM 6 GPA. Okay, not SEM 1 CGPA, GPA. SEM 1 to SEM 5 GPA is there, and I want to predict SEM 6 GPA. Are you getting this? Now, if I say these are all going to be the columns, which are all the columns you will select to train the model out of this? Whether you will consider SEM 1, SEM 2, SEM 3, you will consider. SEM 1 to SEM 5. What about your 10th, 12th mark?
Maybe not.
Okay, that is maybe not. What about caste? What about name?
No.
That is not going to have any impact on the target variable. So now you are understanding it very fine. But if because like you know this domain, so you understand it better. As a data scientist or maybe the people who are going to model, we never have a clear picture on the domain. If it is coming from maybe finance related data set, you may not get it. Whether this particular field is going to have impact on the target variable or not. Okay, so there are going to be some steps there which will be helpful for us to understand which are all the columns are related to the target variable, what we are going to predict. Are you getting? So we have to understand the data that will be coming under exploration. There is a specific set of steps that comes under something called EDA, exploratory data analysis. That gives us clear picture which are all the columns are good and which are all the columns are related to the target variable. So you can neglect all other unnecessary columns, because if you train the model with unnecessary columns, that will have an impact on your prediction. Accuracy will get reduced. Are you getting? So that is what calls a pre-processing and then exploration. Okay. And I also want to talk about this thing because I feel like these are all mandatory things whenever you feel like you want to train a model before that. Okay. So anybody have come across something called statistics like distribution, skewness, kurtosis or kurtosis, anything? So you have to study these parts as well, because I can say like what you give is clear and what you will get, that also will be clear. Or the data, if you are cleaning the model clean data, and the prediction what you get will be clean. If the data what you are going to give is not good enough, the prediction also will not be good. Ultimately, if you think of the wrong one, okay, if I am not giving the correct images to train, then looking at the image, it may be a dirt, or it may think that it is a mat and it will decide to sub that. Are you getting? So what the data you feed will have impact on the accuracy of the model, what is going to gain. Okay, so those steps will be combined under that. And feature engineering, again, I'm not going to deep inside that. Feature engineering, selecting like which are all the thing, and maybe I can tell like given the date of birth, I can create a new column age. Are you getting? That is one of the easiest way of explaining one of the operation associated with feature. I can create new from what I have already, so that it will be helpful. Because if I want to make some prediction on how much, what are the different websites you are going to explore, maybe your date of birth may not be needed, but your age will be helpful to me. Are you getting? So I can derive new fields from what I have already. Those things will come under feature engineering. Okay, and then finally it is going to comes to the model. You got the data, you clean the data, you understood the data. Now you know which are the fields you can use to train the model to get the prediction better. Okay. So now we'll be trying like different, actually it is not straight away you can tell like, okay, for this particular data, this model will be good. You can't tell like, you have to try different models, and whichever model you are getting better accuracy, you have to go with that. Okay. So that is what is that. And then you will be training the model by splitting the data, training, validation. Any other like what do you mean by training, testing, validation? Training data, testing data, anything? How much, what is the ratio you usually use to split training and test data set? 80-20. Whether it is need to be like mandatory 80-20 or it can be anything else.
Keep some data for validation also.
Yes?
Keep some data for validation also.
Yeah, no, that's fine, that's good. Anyway, that's the right way actually to do. What I'm asking is, can we have 75-25? Will it be fine? Or that's fine, right? So it can be anything, but as a standard you can go with 80-20. So what like said, validation keeping it, that is also mandatory, but I don't want to get much deeper at this stage. Maybe we will touch it later. Okay. And then once the model, you split the data, and then after splitting you will be training with the split of training data. The model can be anything, or maybe I can say the algorithm can be anything. Okay. And the end product is going to be your model. Okay. And then after that, you can evaluate the model. Once the model is trained, then you can evaluate it. There are different parameters associated with that. Maybe if this will be classification, whether the given input is email is spam or not. Okay. So can you tell me what are the different performance factors? Accuracy, precision, recall. Okay, so you have all this going to be like comes under that. So we are going to have, it depends on the application. Anyway, if I ask like what could be the performance factor if I go for a house rent prediction, it's a numerical value. If it's a classification, whatever we said, that would work fine. If I ask a numerical value, prediction is going to be, what could be the performance factor? Yes? B? Okay, MAE, MSC, so those are all different, mean absolute error. So that I just stop with that. There's one factor, maybe MAE, MSC, there are different factors. Okay, it depends on application, different factors are there. So you can evaluate the model, whatever you prepare there, using those performance factors, how it works. If it is not working fine, then you go back to choosing different model, training, testing. Okay, so if you feel like the model evaluation is fine, but you need to make it better. So I'm able to achieve the accuracy of 91, 92. But still, if you want to make it, there is a some step that is called hyper performance tuning. So there are different, I can say like there are specifically to deep learning, not specifically to machine learning, deep learning. There are like different performance measures out there. I mean, parameters you can tune. Okay, of course it is there for your machine learning also. It is there, but more prominently for deep learning things. Okay, so you can change the value for those parameters to check increasing the accuracy or maybe the outcome. Okay, so these are the steps whenever we talk about deploying or maybe creating the model. Now, if you follow all this step, the model is ready. The model, if you give the input, then it will predict. Now, I will keep it inside the ROMA. The sensor will sense the image. It give to the model. Model is already trained, so it will segregate, classify it whether it's a human, man, or dirt, whatever it is. Then, based on the prediction, the decision, the ROMA's sensor will suck it. Are you getting? So whatever we are doing now, it's all about preparing that one thing that is nothing but model. Okay. So again, these are the steps, just in this way. And before getting into the model, so there is something like I want to ask, like what you will call data. What is the difference between data, information, knowledge? Because I'm going to talk about decision. Any idea like what is data, knowledge, data, information, knowledge? How do you differentiate?
Data is a raw fact.
Of course, skill plus cost, it's a raw fact. Good. Then, meaningful data. What do you mean by meaningful data? Yeah, process data. It takes skill plus cost. What is the process? I mean, process data means.
For example, if there is a list of students.
Yes.
And a mark for a
Yes.
subject.
Yes.
So that is a raw data.
Yeah.
You can have information like students having marks greater than 40. That's an information from that data.
Okay, so there is maybe some kind of computation. The computation can be anything statistical or maybe just maybe sum of the marks. That is also one kind of processing. Yes or no? Yeah, of course. So now that is what actually select process with data. So you are going to do some kind of computation. You will get the process with data, which will give you information. Yes? Okay, you got the information. Then what is knowledge? I hope yeah.
The failure students are more. You have to teach more. That is the knowledge that is given.
How you will get the knowledge?
Learning.
How you will get the knowledge? So as you said, I got like
Analyzing that information.
analyzing. Okay, anyway, analyzing also still there is some, okay, yeah, of course, that can be claimed by analyzing, but the analyzing is like kind of, I can say like a qualitative term. Okay, like what are the different thing, operation, what it related. Analyzing is, you mean to say like data analysis steps. Interpreting. Okay, let me find. Like I'm going to talk about one simple thing. That's fine. So this is knowledge. Based on the, as he said, maybe I can tell you, maybe some applying rule. Maybe applying rule, you can get the knowledge. So as he said, like you got the total. Okay, you have an individual student's mark per subject. Okay, I'm going to insert maybe the rule, the pass mark. I can insert a rule, pass mark, information with instruction. I will be getting the knowledge about the particular data, or maybe to be specific, the information. I will get the knowledge. With that knowledge, I can make the decision. See, even whenever you talk about data science, decision is the ultimate thing. And before going to that decision, these parts you need. So maybe I can put up this fashion. So I will move fast anyway. So this is, you can consider as a data. Just merely like without like understanding what it is. Okay, so before getting into the data like information, I think something I can want to tell you, like have you, I think even you can claim there is something called a context. Have you heard of like what is a context? You have to see the data with some context, then only you will get the understanding. See, this is data. Raw, you can say like a raw, something raw facts. You can't interpret, you can't understand anything from this. If I say one context, you will understand this. Can I say if you know the context, you will understand the data. Then I think you can map it. What is the possible context here? Yeah, it can be cricket score. If you know the context, then you can interpret the data. Again, you can't get the information, you can interpret it. Okay, now as he said, I am going to apply some maybe there are some going to be process. So as he said, maybe all this data I can create some. Okay, I can do some kind of statistics, maybe calculating the mean, median, mode, sum. All those things can be considered as processing. So once after processing the data, it will give me some meaningful information. So what are the box I gave, like 30, gave something average? This is nothing but information I have. Maybe I have generated after processing the data given to me with respect to the context. Okay, so now I have a data and I have information. Now I have to use some, maybe as I said, some rules. Okay, maybe this is the data, maybe I can say like these are the information what I have already, is history of data. Maybe you think like whatever there is also information from the history of data. Now I am having current and I have history. Now I am going to insert some, maybe I can set a rule. I am going to put some rule. Maybe if a batsman who is, I'm sorry to female faculty if you are not aware of this, just an example so it will reach. Okay, so like if I set a rule that maybe a person or a batsman to be the topmost or the best, so he has to score at least 2000 runs. If I am going to make a rule, okay, then I will get the knowledge out of the information whatever I have now. Are you getting? So that the information can be anything, maybe the knowledge can be anything. Yeah, the knowledge based on the information on applying the rule, I will be getting the knowledge maybe something like out of form. The out of form is nothing but the knowledge I just derived from this data. Are you getting? This knowledge will be helpful in making the decision. Are you getting? So this is a simple example. You take the same example in the industry level as well. If they want to take a project, if they want to release a person, the decision can be anything. But these are the process they will be going through to make a decision. Are you getting? So this is also going to be a part in your data science. Okay. Now I go back, machine learning. Okay. So if I talk about machine learning now, okay. So I just talked about the AI and arriving to a maybe model creation or intelligent system creation steps. Now I am going to give us steps how to create that model. Okay. So maybe that's a person called this is generic thing, but I want to explain this part alone. Okay. So there is something called traditional modeling or traditional programming and then machine learning based programming. Okay. Clearly what you used to do, we used to do, we will write a code or we will write a program. Okay. And we will give maybe we will write a program, maybe I can give here, we will write a program, maybe C program adding two numbers and we will give the data A and B, so maybe 1 and 2. So program as well as data we will give and computation execution will happen and you will get the result. That is what a traditional programming formula whatever we used to do. Now with respect to machine learning, what is going to happen? See, we are going to give data and also we are going to give the result. Remember, data and result, and there it is going to be computation. That is nothing but the execution or maybe the execution of the code. Okay, and result is going to be program. I think I just want you people to understand this. Can I tell like what is this data means? Here, what is the data? Take the rhomba itself. Take the rhomba. If I say like data, what is this? The different images, as I said, right? Different images, that is data. And what is result? Results are nothing but the labels associated with the data. So if I give one image, this is the image of chair, okay, label will be attached to that. The result is chair. And I will be giving an image of one dirt, collection of dirt. I will attach the result as dirt. Like that, some hundreds and thousands of images with its result. Are you getting? I will be giving it to one algorithm. Algorithm will take data as well as the result of the data and the algorithm is going to do something. That do something is different for every algorithm. If it is like a decision tree, what it is going to do here is different. If it is going to be SVM, it is different. If it is going to be CNN, it is different. Are you getting? So what the process is going to do here, it is different. So what you are going to get is nothing but the program. The program is nothing but model. Are you getting? The program what we are going to get we are going to do decision tree. So assume like decision tree is going to be there. You are going to give data and result. So the decision tree algorithm executes. Okay, otherwise it trains the model or trains the algorithm. The output of that is going to be the model. So you can take that model, take it out. Okay, there is a lot of ways to take it. Okay, take it out and you input one image. The model will predict whether it is dirt or it is a human or it is a mat or anything. Could you able to understand? So that is the way or the approach we will be using now for a machine learning, unlike a traditional way of programming. Okay, so now this is the formal way of defining what is machine learning. Maybe you can go with the author called Tom Mitchell. It's the standard. Maybe I guess if you have followed machine learning, he is the first author. Maybe anybody will suggest you to go through. Anyway, it's more mathematical. It is one of the basic level of books which exemplify the machine learning in a better way. I think now you just read through this, you can understand it in a better way. So a computer program is said to learn from experience E with respect to some task T and some performance measure P. If its performance on T as measured by T improves with experience E. Maybe it is a little bit confusing if you read maybe very first. Maybe I can tell you one thing. Assume like this rhomba itself. Assume that the rhomba itself. Maybe I can select I am having this. I am having this. That's the algorithm is there. Right now the algorithm doesn't know anything. So it is going to learn one by one. Okay, it is going to learn now based on what I am going to do. Okay. So the computer program, that is algorithm is there. Okay, it is going to learn from the experience. Experience is nothing but what is there. In this case, what is that experience? Experience is nothing but prior one, nothing but data. So I am going to feed or I am going to have look at that. So learn from experience, nothing but the data set. Experience is nothing but the data set, and with respect to some performance factor or task. Okay, performance with respect to some task. In this case, Rhomba, it is image recognition. In case of your Tesla car, detecting what is the object. So there are some tasks associated with. If you take Deep Blue, the next to movement, the chess playing is the task. So every machine is going to have some task, right? So with respect to task, okay, and performance measure P. P is nothing but detecting correctly or not. With respect to Rhomba, if it is selecting dirt correctly, yes, it is correct. If it is detecting dirt as a human leg, that is wrong. Okay, so you will call it as accuracy, precision, recall, all those measures. Okay, now I have a set of data and for the specific task and I have some measure. Now my model is going to tell like it is going to learn. When I will say that it is learning, okay, when it is performing the task T, then measured by P and improves over the E. Assume like I have 100 images. I take only 10 images. Okay, and I train my that image 10 images nothing but E as of now. 10 only 10 E. Okay, and I am going to use this 10 E for the 10 specific task T to image recognition. And after recognizing, so I will test it with the performance factor. Performance factor may be accuracy might be 10% or 0.1 or 10%. Now next what I do, again I will increase the experience, add 100 more images. Again I will try it and again I will test it with the performance factor P, accuracy will be 0.4. Now I can say my model is getting learned. Are you getting this? With this understanding if you read, you will understand it. Again I will take more experience, that is more data, 100 more images. Again I will move to the algorithm or a computer program in that perspective. Again I will test it, I will get 0.7% of accuracy. Now my performance factor is increasing with more experience I am giving to the algorithm. Now I can say my algorithm is learning. Are you getting? So at some point of stage, my algorithm will get a performance factor, okay, P at 1, that is highest one. Then I will stop learning, then I will make the model is ready to go for prediction. Could you able to understand? Yes? So if you read that, so the computer program is said to learn from the experience, that is the data, for some task, which is going to be measured by some performance factor, accuracy, recall. And its performance is going to improve, okay, with respect to the performance factor P. That is what it is mentioned. Okay. So the model I can say like it is going to learn. If its performance factor is getting increased when I change or more or increase the experience. That is why I guess I will ask you like why your data science got into picture suddenly. Any idea? Till 2007, 8, 9, maybe around till that time, there is no talk about data science. Python was there. There is no talk about data science. Any idea like why suddenly data science got into picture? Processing power is one of the constraints, but main thing is yes. Models is not there because we don't have the ultimate backend thing. What is the backend thing? Data is not there. Are you getting? There is no data. We don't have that big E. That E, whatever I said. So here I was saying something E. We don't have that E, large amount priorly to make the model learn. Are you getting? The model to learn, we don't have a large E before. Okay. Once the internet exploded, all those click everything, big data emerges, then we got a large amount of data. So that large amount of data is used to train. Are you getting? So the data is going to have a primary role in modeling. Okay, so in making the model learn. Okay, so that is what the thing also says. And these are different examples. I don't want to talk about it. Different example for TPE before this slide. Okay, so once after this slide, if you read through this, maybe you will understand maybe what it is. But I already gave you some example. So I move next. So now this part. So this part is going to be algorithm. So there are different algorithms we are going to talk about. Supervised, okay, especially like machine learning, supervised, unsupervised, semi-supervised, and then reinforcement. So if I ask like how you will say like simple way of supervised and unsupervised, simplest way. Yeah, only thing is label. So if I keep chocolates, fruits all together with that label, and I will see the student, will see the kid, okay, look at it and read it, look at it, read it, look at it, read it. So I kept 10 different things. And 11th thing I will keep only the item without the label. The kid has to tell what it is. Just like that. Okay. Now if I say like the unsupervised, what do you say? Unsupervised. I am not going to keep anything labeled. Nothing is going there. Only chocolates, different chocolate variety, fruit, all those going to be there. Now, without knowing the label, I have to group it based on their characteristics. Each and every item is going to have its own characteristic, right? Which are all related to one another, I am going to group. Maybe, I think, have you heard of something called similarity check? Similarity measure, similarity measure? There is a distance measure, is there anything else? Yes? Similarity measure?
Things will be compared, there's relatively change.
Yeah, the things will be compared, similarity measure, that is our visual. Maybe computation wise, any idea like what you will call similarity measure? That is centrality. Yeah, Manhattan distance is one of the measure. Euclidean distance, any other measure? Sine, cosine measure, anybody come across how if I give like a two vector or two values, how you can calculate the maybe the distance or the similarity of these two? There are different measures are there. Cosine measure is there, as it is Manhattan, Euclidean, and this goes lot of measures are there. So what I am going to do, I am going to give you two items. Using any of this, you are going to calculate the similarity or distance between these two items. Now, for each and every item I kept here, I am going to calculate the distance between each. Whichever is having very less distance or more similarity, I will keep them together. Here I am not going to have any label here, but I am just going to understand their characteristics, and based on the characteristics I am going to calculate the distance between each. Whichever all feels like closer, I am going to group it together. Now at the end, I will be having some cluster where all chocolates are together, all vegetables are together, all fruits are together. Are you getting? Now, if I am giving one new object, okay, take this, which group it belongs. Then I have to check it, yeah, this is, if I feel like I'm looking at characteristic, then I have to check for this characteristic, which group I have to keep it. The model should know. Okay, so maybe if I give chocolate, okay, these are the chocolate having this wrapper is there and it is very small. These are characteristics. And with this characteristics, it compares with cluster 1, which is how much distance it is for this. And then with cluster 2, and then with cluster 3. And among these 3, whichever is the short distance, then you will try to put here. Are you getting? Now, this is the performance measure. How clearly it is classified. This is with respect to clustering. Here you don't have label, but using characteristics, identifying the distance, you are grouping together. This will be considered comes under unsupervised. There is no label, just based on the characteristics alone. Okay. And then what about semi? Semi is combination of both. So as simple. You have both labeled data will be there, unlabeled data will be there. You will use both the concept together to train your model. And what about the last one? Reinforcement learning. Yeah. I want to give an example, but I don't want like being a kid, have a kid. Okay, just show something to the kid. Okay, maybe a chocolate. If the kid is saying like fruit, slap. Okay, slap it is not right. So it is something else. So he will he will tell next. So again one slap. Okay, it is not. It's also okay. Next time chocolate. That time there is no slap. Okay, giving him one chocolate. So he will understand whatever I did is correct. Okay, so from that he will learn. Next time again you show maybe a vegetable. Again he is saying chocolate, slap. Okay, this is not chocolate. So in this vegetable, once he is saying vegetable, you give a chocolate. Okay, so he will understand, yeah, I am getting something good when I am saying this to this particular characteristic. Next time if you show that for that particular characteristic, he will predict it correctly. I am not talking about K, the procedure. So it is all about reward and feedback. So you will no need of any data set. Even you can go for a reinforcement learning, even without any data set also it works. You just have an algorithm, just give it some scenario. Based on scenario, what it is going to act. If it is providing positive feedback or positive performance, give it a reward. If it is not creating positive feedback or a positive action or a performance, give it a negative feedback. Maybe where this will be helpful is maybe the piece I said, the environment. If you doesn't know about how the environment is going to be, then reinforcement is the best way of doing. Maybe I can tell like, can you create all possible data and label that are going to be expected in mass? I never know what is going to be there in the mass. Even I have some, but it is not everything is clear. Are you getting? So I want to create one machine that is going to do everything on the mass. Maybe if I have every detail about the mass, I can train with the supervised learning, I can make the model. But if I don't know anything, what it is going to be there, then I will make a model and I will put all the positive negatives that are associated with that model. Which are all the action I can consider some positive, which are all the thing I can consider negative. So I will make the model, put in the particular environment wherever it is going to be. It does some action. So something will happen. Response will be there from the environment. Based on that it will decide whether this action is correct or not for this particular situation. So the model will learn on its own based on whatever the criteria you have given. No need of separate training is required. Are you getting? So those kind of environment are maybe the thing you can go for reinforcement learning where explicit learning is not required for a model. Model will train on its own by doing error, mistake or doing the things correctly. Okay. So this is what I just discussed now. Feedback based on all those things. So I will move next. Yeah, maybe like in general, like whenever we talk about supervised learning, usually there will be two things will come into picture: regression and classification. Regression is nothing but if you are going to predict some continuous value, it will comes under regression. And whenever you are going to predict some category based, then it will comes under classification. Maybe then I will ask like what is continuous? When you will call a data as a continuous and when you will call the data as a discrete. You know, two types of data is there. One other way, discrete data and continuous data. When you will call the data as continuous, when you will call the data as discrete. Continuous means?
Changes with respect to time.
Changes with respect to time. Anything else, any other way?
Every point there is while you continue.
See, you can't precisely tell that if you say the value, still further maybe micro level values might be there. If I ask you like what is your weight, okay, you will 70.01. And if you look closely, it will be 70.0.001. Again, it might be 70.0000101. It goes. You can't precisely tell a value. Are you getting? Those data can be considered as a continuous. Discrete, if I ask like how many fans are there is no other 0.01, right? Are you getting? It might be 6, 7. So these kind of data can be considered as a discrete data. Are you getting? Now, I just, why I said like I want to know like what is the continuous data. Continuous data is nothing but any value that are going to be in general numerical flow. So as I said example, predicting a mark of a student, okay, that comes under regression. Okay, predicting maybe as I said, like cost of a house, or maybe once you give all the details, where the house is, how many floors, how much square area, when it is built, all these details I give. You want to predict the price or the rate of the house. Such a problem, prediction what you are going to do is a continuous value, right? So that comes under regression. Okay, now I go back next, like predicting whether the email is spam or not. Okay, that comes under classification. Alright, so primarily supervised learning can be of two types primarily, that is regression and classification. Regression will be continuous value, classification will be category, not necessarily two, it can be multiple as well. Okay, and then unsupervised, there are other types also there. Primarily we will be talking about clustering, what I said. Given 10 items, I clustered into chocolate, clustered into vegetable, clustered into fruits. Okay, so that is one of the prominent way of maybe comes under unsupervised learning. Okay, and reinforcement learning it is there, just feedback and then reward based. Okay, so what I was discussing, and maybe I can put up with this. The plan I just made like. Yeah, the thing is going to be like this. Okay. So it move like this. So supervised learning, you can keep it like this. So supervised learning is going to be something like this. Data is there, data is there, and I am going to give along with the label. So as I said, image, leg, human, carpet, everything. So the model will go. When I give the picture without knowing what is there, then the model will predict what it is. Whether dirt is there, or human is there, or mat is there, it will predict. I think you can understand from this image what I discussed. Yes? I will give data like this. Every image will have with caption, or maybe I can select with a label to try. And once after trying is done, I will have the model. The prediction model there, I feel like it is a model. So if I use some test data on image, then the model will predict whether there is a human in the image or dirt in the image or whatever it is. The prediction will be there. So this comes under supervised with label. And of course, unsupervised is going to be clustering. So it is not going to have any label. Okay, maybe this diagram will be there. So there is no label. Just give whatever the data you have. And the characteristics I said, you will extract the characteristics. That is nothing but specified as a vector or a feature vector here. So you are going to extract the characteristics of the data whatever given. Okay, and then you are going to make the model, learn. Okay, and whenever you are giving new, maybe to predict, so it extracts the features of it and compares the features based on the cluster whatever we have, and then maybe it will make a which particular cluster the given data is likely matches. You give the cluster number or cluster ID or which cluster it belongs. As I said, like if I give chocolate here, it extracts the features and already I have a different clusters. And which cluster this particular characteristics matches, then it will give you. Okay. And basically next what I am going to is I am going to give you some idea on the basically the plan is 1.5 hours for completing this. Okay. Basically I want to plan like going before regression or machine learning, like I want to say like machine learning is nothing but another domain in mathematics. I don't see it is comes under mathematics anyway. What is it? Machine learning is nothing but there is another maybe field. I can say it's a field. It's not it comes completely under mathematics. What is it? It is statistics. So if you are very good in statistics, you need not to think anything about machine learning, you are ultimately good in machine learning. Even I can say like a deep learning understanding also you can make it very easily if you are very good in your statistics. Whatever you used to say like statistics, now everything is in terms of machine learning or whatever the deep learning, everything in terms. Maybe you might have seen these kind of images, maybe I just want to put up something like this. The same y equal to mx plus c, we used to learn the equation of line, that is nothing but your linear regression actually. Truly that is what linear regression. Okay, so similarly you might have this and something like this. Maybe this will give you some idea what it is. So there is no person as a data scientist who does know statistics and who can implement it through Python. They can be a Paka data scientist. And if you feel like you are good in statistics and you can learn statistics good, you have a very better scope of becoming very good data scientist. Or you can make the model in a better, or you can do a research in a very good fashion of creating your own model or a better model using statistical based, maybe the techniques, algorithm, whatever it is. Okay. Because the thing I am going to show also maybe you might understand it. Yeah. So before getting into like, now I am getting to supervised learning. And before getting to supervised learning, I want to talk about something called regression analysis. I just move forward. Okay. Maybe I told you people like, assume like I have an age, assume like I have an age and I have a maybe weight. I have two columns. Assume like that's I wanted something to write maybe. Just otherwise I will draw in there. Okay. So assume like I have a data set. One is age of a person or a age of a person or a collection of humans and their weight, age and weight. Okay. Now I want to train my model with age and weight so that maybe suddenly if I give one age, my model should predict what could be his weight. Again, this is my requirement. Assume like this is my requirement. Now what I have to do, can I plot it like this? Can I plot it like this? Maybe age of the person, weight of the person, something like this. Statistic I can do, right? Now, yes, fine. Now what I have to do, I have to make one line. Okay, I have to make one line in such a way like this particular line should be maybe I can say like simple way like should be at the middle of all the points. Should be at the middle of all the points. I have to make a line in such a way like this line should be middle of I can say like maybe otherwise I can calculate the distance of each and every point. Maybe the line, the distance between the point. Okay, calculate all the distance between each and every point and the line. Okay, and there will be some total sum will be there, right? Total sum of distance of all the points. Assume like it is a value. Then change the line somehow down or above. Then calculate distance between all the points with respect to the new line. There will be some value you will get. Now assume like make the line different places and calculate the distance, total distance. Whichever the total distance is least, you can assume that line is at the center part. Yes or no? Simply it is statistics. Now this line is nothing but your regression line. If the regression line is what is linear regression is all about, making that one line. Okay. Now once you make this line, okay, if I give you the age, if I give the age equal to 30, just draw a straight line and wherever it cuts, draw the line here, that is going to be the weight of the person. Are you getting? Previously we used to say it is a statistics. Okay, now it is comes under, maybe I can put up in such a way like a modified and maybe like a better molded way of representation of our model preparation. That comes under linear regression. Would you able to understand? So I just go like this. So this is linear regression. And now, again I said, regression is for continuous value. Age and weight. Weight is also continuous value. Okay, prediction, that comes under regression. Now I am going to make something like this. How it will work for logistic regression. There are what the different I am going to discuss this. Logistic regression, decision tree, I will explain more. Okay, and then I will be explaining about clustering some idea. Then I will jump into implementation. Okay. So now what I am going to do under logistic regression, assume like it is not going to be like a continuous, it is discrete. Maybe I say like sparm or not. There are possibly two values. Or maybe he's maybe I can put up in maybe he's Indian, Australian, or maybe USA, something possible, different category rather than continuous value. Okay. Maybe something is given here. Whether the customer will buy the insurance, yes or no. It is going to be category rather than continuous value. Okay, so these kind of prediction you prefer or you will go with logistic regression, not with linear regression. Okay, so my ultimate plan is not about discussing linear regression, but without discussing linear regression, if I come directly to logistic regression, there will be one point will be missing. Okay, so that is the reason I just said what is it. Maybe you can think of this. Okay, so maybe you take this as a data set. Now I am talking about logistic regression. Age of the person, whether the person have insurance or not. Assume like 0 represent no insurance, 1 represent yeah he have insurance. So now I can plot it like that. Maybe if you take an age, whether insurance is there or not. 0 means no, 1 means yes. And I am plotting all the points. Now what I can do, if I am going to follow regression or a linear regression, if I draw a line, then it will be there. Okay, maybe something it looks like that. And if I am going to calculate something like if from age of 50, the person will have that or not. So it will be something around 0.6. So the prediction is not like as wanted. So linear regression will not straightly applicable in this case. So we have to go for something else where the outcome will be always between 0 and 1. Are you getting? The prediction should not be in continuous value. The outcome should be either 0 or 1. 0 represents no, 1 represents yes. In case of binary. In case of multi-class, it will vary a little bit. I assume now for binary classification, either 0 or 1, yes, no, male, female, something like that. Okay, so that is going to be like, if you look at closely, so there is a line here, okay, and then suddenly it goes up and it goes there. Now if you look closely, the line, mostly it will be either 0 or mostly it will be in 1. In between there is a region that will be done based on probability. The portion alone will be done based on probability, or you can keep a threshold of 0.5. If it is more than threshold, you can keep it maybe 1, and if it is less than threshold, you can keep it 0. Are you getting? Now, I'll just go here. I think I'm not sure whether thing is visible. That is nothing but your equation of straight line, y equal to mx plus c, that you remember. And what do you mean by m? M stands for slope, c stands for intercept, right? You used to say like it is intercept, where it cuts x-axis or y-axis? Y-axis. So that is the logic. Now the same we are going to talk about in linear. I think I could have kept the equation for linear regression also. You will understand. It will be something like this. Y equal to beta 1 x plus beta naught, same as mx plus c. Are you getting? Same as mx plus c. Beta naught you will consider as one parameter, and beta 1 is the m, and beta naught is constant, something same as that. Okay. Now if you look at the top, okay, maybe again I need something like a mx plus c. If any writing there, then it will be easy like to tell them. Board. No, board is it's better. So mx plus c, see I can say like x is only one value. Assume like there are multiple x's are there. I can tell like m1 x1 plus m2 x2 plus c. The equation can be like this. If x value is very multiple, maybe, but it will not look in a 2-dimensional. You have to go in a plane way, 3-dimensional. If it is m1 x1, m2 x2, m3 x3, then it will be 3-dimensional. It will be. Are you getting? It cannot be projected on our own, but that is how it looks. Okay. Now assume like there is an equation. The top equation, if you see, that is same as your linear regression. Now down there is something called that is specific to logistic regression. Otherwise you will call this a logistic. Maybe I can put up this. There is a formula like 1 by 1 plus e power minus x. I am not sure is it visible. The formula is 1 by 1 plus e power minus x. Whatever the x value or whatever the u value I derive there, okay, I have to replace it with the u. The prior formula is something like u equal to b0 plus b1 x1, it goes and it can go up to bp xp, assuming p is the number of parameters. And once I calculate it, I can apply it to the non-linear part, the value of u, that is 1 by 1 plus e power minus u. Whatever the value I get for u, no matter how big it is, then the value of y will be always between 0 and 1. That is what going to be in this case. That is linear part. X value increases, Y value also increases. Linear part. Because it is straight away, maybe I can select a sum of multiplicating of X. So it will, if the X value increases, ultimately U value, the first U equal to, that will increase, linear part. But when you come to the logistic part, it is non-linear. No matter of what is the U value, if you apply to the logistic formula, then you will get always Y value between 0 and 1. Now, no matter you have like age, you have your maybe GPA 1, GPA 2, GPA 3, and your final thing is going to be like you will get pass or fail. Okay. Now, no matter what is the calculation you do, the final decision will be always between 0 and 1. Are you getting? Then you can keep a threshold and you can make whether the student will pass or fail. Could you able to understand? So that is going to be for your Oh, is there? Because it is there, break is there. Oh, my plan. Okay. So I just want to skip this. Maybe I will slide the share. So this at what time? 3:32. Okay. So whether you are aware of like decision tree, how it works, any idea like what is JV, purity, impurity, anything like that, how it works, how decision tree will be formulated? Because simply if I give data set and you give some 4 lines of code and you will get the decision output, then it is not good to show you that. You should know like at least how the decision tree at least formulates. At least it will be a basic for you people like to move further. Maybe I will. So this is the plan. Like I just want to given the data set, I want to tell you like how this decision tree will be formulated. Once if I give the sample and the decision will give you the prediction yes or no as output. Okay. So that is the plan. Because once you know decision tree, ultimately you can understand random forest or those tree based all those predictions. Very simple. Okay. So ultimately, I plan is to stop with the decision tree. Maybe I will take 2 more minutes. Decision tree, I guess that there is a formula for Gini impurity. Okay, this using this Gini impurity, you can calculate like you can make this graph. So that is some calculation I want to explain anyway. So I will move. So these are the formulas. See, once after this calculation, this data will result in this model. And if I give input, maybe the going to be astronaut is the prediction. Age, likes dog. Assume like there is a person. The person age, whether the person likes dog or not, whether the person likes gravity or not, and is going to be astronaut or not. I am going to predict. So given the data, his age, whether he likes dogs or not, whether he likes gravity or not, I am going to predict whether he is going to be astronaut or not. So this is the data is given to me. The prediction target variable is the last one, and these are all independent variable. So using this independent variable, I am going to make this decision tree. The logic I may not explain now. Maybe if I give like one example, age is 47. Age is 47, and he likes dog. Okay, I put like a 0. He don't likes dog, and he likes maybe gravity. Is there examples there? More than 40, 0, 1. Yeah, more than 40, 0, 47 is there. 47, 0, 1. So I'm going to give same example itself. Okay. So go to that first one. Likes gravity or not? So likes gravity, yes. So it comes here. Okay. So it comes here. Okay. And then after that, likes dog or not? No. Okay, it comes here. Whether the age is more than 40, yes, it is 47, and it goes to S. Are you getting? Now, my model will predict for this sample input, the output is yes. Are you getting? Now, you have to understand how this tree is getting built. Once you give one line of code, your Python will do the building, but you should know like how it is getting built. Okay. So that is the logic I just wanted to explain. So this I don't think like, and I will stop with random forest is nothing but like having multiple trees. Every tree will give you the output. output, and the output will be consolidated. Whichever is having the higher vote, which class is having higher vote, will be given as an output. Assume like you have only one tree, and the tree is giving you output. Now I am going to have a forest, collection of independent trees. Each tree will give me one output, and whichever output is having more prominent of all the trees, then I will give it as an output. That is what random forest, collection of individual trees. Okay, and there is something called XG boost is there, one model, which will be nothing but it's not an individual trees. Each tree are interrelated. Output of one tree will be consecutively input of other one. So the prediction will be done at the end. So if you are understanding decision tree, it will be well and good. And plan for it. Anyway, I just have to maybe before, because I want to start implementation straight away after that. Okay, unless it will be delayed. So I want to have this. What is this like prediction? Maybe, but I don't want to extend up before that because there is a proposal complete today. I want to raise call me to submit in a stage by 5 today. So here, so I need to engage it. Even I can engage it here itself. Like by the time I can complete. Yeah, and then clustering is going to be there. Okay, I want to touch up this clustering as well. And maybe I will explain only one thing, then we will go. Like clustering, assume like these are the points. I told you chocolate and those things. That is, understanding it is fine. But how we maybe simply I can put up like this, maybe a distance space, I will explain in this way. Not this. Yeah, I just explained you. So this is going to be my data set. Okay, and I'm going to make a cluster out of it. Okay, simply putting, you just make it like this: leaves, petals. My flowers in a data set form. Now I'm going to group it together. So how your clustering works? Simply to put simply, maybe X, the feature X1, feature X2. So I'm going to have X1 and X2. Based on the value, I just put a corresponding flower. Okay. Now I will have some point randomly. There are going to be some points randomly. You just talked about centroid points, right? Centroid. Assume like I'm just having think like the number of clusters is going to be decided on your. There are different techniques are there. Elbow method is there. Single method. Lot of techniques are there to identify how many possible clusters can be for a data. In this case, I assume 3 clusters. Okay. So randomly 3 points are there in my plane. Okay. They are random. Now what we are going to do, calculating the distance in this case. So I am going to calculate the distance, whichever the maybe the point, I will say the data point, whichever the data points that are closer to each cluster centroid. Maybe if you look at pink color, yeah, it is closer 2. And this one, actually it is 3. So it is closer to this point. So only that one will be in the first group, and this 2 will be the second, this one, and next 2 will be this. And all other will be to that. Maybe you can see like this. Initially, based on the distance, the cluster will look like that. Yes, sir. Initially, with random points. Okay. Now, I have to calculate mean for the centroid point. I am going to calculate again for that one cluster. Only one item is there. So the centroid point is nothing but the particular point only. So my point will become something like this. My point will become something like this, first point. And second point, I have 1, 2, 3, 4. So 4 different maybe records are there. I will calculate the centroid of all the 4, which will lie somewhere around here. Okay, my centroid points getting changed. Similarly, I will calculate for that 4. So it will somewhere lies here. Now after recalculating the centroid point, I have to calculate the distance of each other item. So now which other items are closer to that point will be clustered, and this point will be clustered. Now if you look closely, that will be closer. Yes or no? So this will form a cluster, and this will form a cluster, and all others will form a cluster, something like this. Now this will end up like this. Okay, now again calculate the centroid point for whatever the items clustered now. So centroid point will change like this, and the centroid point will change like this, and centroid point will change like this. Now, no matter how many times I try here onwards, the centroid point will not change because the group will remain same here onwards. I can say the threshold point is reached. Could you understand? Now, no matter what is the, maybe if I give like, maybe if I give x value equal to 1 or 2, y value, sorry, x2 equal to 3, then that will be in cluster 1. If I give a sample input which is having a x1 value of 0 or 1 and x2 value 4, 5, 6, then it will be in the cluster. Are you getting? So this is how a clustering will be formed considering distance, similarity measure. Okay, here I gave the similarity measure just as the Manhattan distance. What I followed here is Manhattan distance. I guess you know what it is. Okay, similarly you can follow other way of distance like a cosine similarity distance, or you can follow Euclidean or other way of measures as well to form a cluster like this. Okay. So it's a small demonstration. Random points will be there, and after every iteration, the point will change, and the grouping also will change, and finally it will settle down with some group. That will be your cluster. Okay. So I stop it here. You can go for the T. I will start with the demonstration here. Yeah.
Please be back by 3:45, only 5 minutes break, and please kept outside.
ഇതിങ്ങനെ അതും ഒന്നും നമ്മുടെ ടോപ്പിക്
ലൈവ് ക്ലോസ് ചെയ്യണ്ട.
Close ചെയ്താ?
അല്ല ക്ലോസ് ചെയ്യണ്ട.
Close
അപ്പോൾ ഞാൻ പോന്ന അലോണിയില്ലേ
അല്ലെ ഞാൻ